Lesson 18 is all about doing different types of word problems today. Alright, so the hardest part of coming up with today's is not necessarily the math, but it is getting the actual equations for each one of the problems here. Alright, now I think it's easiest to just go word by word here. Alright, the number of blues was, so equals, 4 less than the sum of the whites and the greens. So it's 4 less than if we add those two together. Alright, so the sum of white and green, so we're going to add those two together, minus 4. Alright, there's our first equation. Also, the number of greens equaled the sum of the blues and the whites. How many of each were there? If there were twice as many blues as whites, so there's more blues than there are whites, so B would have to equal 2W. Alright, now there's lots of different ways to do this. You could use your calculator to solve this, but we have to have all of our variables on the same side. So if you did that, for the first one, we'd have to move over the W and the G, and that would be equal to -4. For the second one, we'd have to move over the B and the W, and that would equal 0 then. For the bottom one, we'd have a positive B, a -2W. We wouldn't have a G, so if you're doing the matrix, you'd have to throw a 0 in there, and that would also equal 0. So that's one way to do it. Okay, another way to do it is you could just do substitution. We have G equals this, so I could plug this in there for G. So I'd have B equals B plus W minus 4. Alright, so then I could solve this equation for W, it looks like. I could subtract the B over, which gives me a 0, equals 2W minus 4, add the 4 over, I get 2W equals 4, so W has to equal 2 here. Then I could throw that 2 right in here, so B has to equal 4, and then for this equation here, 2 plus 4 is 6, so our greens have to equal 6. And then I could check that by throwing that into the original. 2 plus 6 is 8, minus 4 is 4, which is what we got for our blue here. Alright, so you could do a combination of a lot of things. You could either do the matrix, like you guys like to do, or you could do substitution, and this one falls apart pretty quickly there. Alright, next one. Reds vary directly as blues squared and inversely as greens. Now this is a direct variation and an inverse variation, so that means we have a joint variation here. Alright, so what that is we have to find our K value. And this is another one where you can just do it just as it's written here. Reds vary directly, that means divide, because it starts with the same letter, as blues squared, and inversely means multiply. So there's our equation, and then we just start throwing stuff in here. So K equals, we've got 80 reds, we've got 4 blues, and 2 greens. So 80 divided by 16 is 5, 5 times 2 is 10, so our K value here is 10, and then we use the rest of our information with the same equation. So we've got 10 equals, our reds we don't know, our blues we've got 8, and our greens we have 10. Alright, so we've got to solve this equation. For R, we can divide by 10, so 1 equals R over 8 squared is 64. Multiply both sides by 64. Our R equals 64 here. Alright, it's much easier to write these equations just going word for word, I think. Next one, the sum of the digits of a two-digit counting number is 5. Alright, so when we have, there's two different ways to do this, I'll show you both ways. When you have a problem like this, our two digits would be our tens unit and our ones unit, okay? Normally we would say a 0 or an O there, but it kind of looks like a 0, so I would get rid of that. Alright, so we could write an equation here. So t plus u equals 5. Alright, and then it says, when the digits are reversed, the number is 9 greater than the original. Alright, so say we had the number 47. We could write that as however much our t is times 10. Alright, well we know that our t would be a 4 here, so that gives us 40 plus u times 1. And then when we plug these in here, our 4 would go here, there's our 40, plus 7 times 1 is 7, there's our 47. So, when it says the digits are reversed, we've got our units digit would come first. So, units times 10 plus t times 1, or just a t, equals the original number, so that's where we come back and use this equation. The original number, so t times 10 plus u plus 9, because we gotta add that 9 in there. Alright, so now what we have is we have two equations with two variables. We could do, well, we could simplify this equation down. Alright, so we've got, we can subtract the u over, so this is 10u minus u, so we've got 9u. Alright, so we move this over, we've got negative 9t equals 9, and then we've got t plus u equals 5. Well, we could multiply by 9 here, and then do elimination. So we've got 9u plus 9t equals 45. So then the t's go away. 18u equals, what is that, 54? So our units digit is 3. And then that means our tens digit has to be 2. What was the original number? 10 comes first, so 23 should be our answer here. Alright, now there is another way to do this. We know that we have a two-digit number. And we know when we add up the two digits, they have to add up to 5. So our numbers would be 50, 41, 32, 23, 14, and 5. When we reverse those, when we reverse the 50, that's a 5, 14, 23, 32, 41, and 50. Alright, what this says is when the digits are reversed, so here's our reverse column, the number is 9 greater than the original. So our reversed column is 9 more than our original column. Alright, is 5 9 more than 50? No. Is 14 9 more than 41? No. Is 23 9 more than 32? No. Is 32 9 more than 23? Yes. Alright, so then we just have to answer the question. What was the original number? Our original number was 23. So, here is our algebra way to solve it, and here's our logical way of solving it. Both ways work, doesn't matter to me how you solve it. Kind of depends on what the question is asking, with which way to go with it. Alright, so it's up to you. Next one, to get 1,000 gallons of a mixture that was 56% alcohol, it was necessary to mix a quantity of 20% alcohol solution with a quantity of 80% alcohol solution. how much of each was required. Now, big question with this is, are the two solutions the same? And the answer is no. All right, we have one that is using 20% alcohol, and the other one is using 80% alcohol. All right, so because we've got two variables, we're gonna have two equations here. One of them is, we've got 1,000 gallons overall. So x plus y equals 1,000. The other one, we've got to use those percentages. All right, we know that one of them is 20% alcohol. So we could say that we have 0.2 x. All right, so 20% of x plus 80% of y. All right, now notice what this is this is percent times the total amount of that plus percent times the total amount of that equals percent, so 56%, times the total amount of that, which is 1,000. All right, so we can simplify this equation down a little bit. 0.2x plus 0.8y equals, what, 560? All right, and then different ways to do this. You could multiply this by 10. All right, so 2x plus 8y equals 5,600. All right, and then maybe you want to do elimination. Again, you could multiply this by -2. So -2x minus 2y equals 2,000. Add those together, x's go away, so we've got 6y equals 3,600. So then y has to equal 600. All right, and that would mean that x equals 400. All right, and then you could throw that into the other equation to check it. But now you need to tell me exactly what that means. So we've got 400 gallons of, the 400 was the x, so of 20%, and 600 gallons of the 80%, okay? It's very important to put this part down too, because we gotta know how much of each one is required to be able to get this 56% solution. All right, now if you think about this logically, if you average your 20%, 80% together, that's 50%, all right? So if we were asking for 50% alcohol, it'd just be the same amount for both of these, all right? But because this is more than 56, that means we're gonna need more of the higher solution. If this were less than 50, we would need more of the 20%. So you can at least get a ballpark, you can kind of figure out exactly where your answer should be, like a range for it. Okay, so be aware of that. That might help you out when you get to the end on what to expect for an answer. Now this one's a little bit different. How many liters of a 64% glycol solution must be added to 77 liters of a 23% glycol solution to get a 42% glycol solution? All right, now we're doing the same thing, except here's the thing. We already know how much of one of them we need. So what we're looking for, this is the only thing that we don't know, is this 64% solution. So we could do percent times the total amount for that one, plus percent, so 23% of the total amount. Well, we know that that's 77, so we can throw this 77 in here, equals percent times the total. Well, the total is always adding this plus that. Well, that's x plus 77 here. All right, so this time we only have one thing that we don't know. So we just have the one variable. So we're gonna have to do some algebra here to be able to solve this. So the 23 times 77 gives us 17.71. Over here, we're gonna have to do the distributive property. So 0.42 times 77 gives us 32.34. Alright, so then we're just solving for x, so move this over, so we've got 0.22 x equals 3234 minus 1771 gives us 14.63. Divide that by 0.22 and we get x equals 66.5 liters. And there's our answer for this. Alright. Okay, moving on to the last one here. The weight of the carbon in the container of C3H7Cl was 113 grams. What was the total weight of the compound? Okay, it's important to know our carbon is 12, our hydrogen is 1, and Cl is 35. Alright, so we could come up with a proportion here to be able to solve this. Alright, and what that proportion is going to look like is first we need to figure out exactly how much this entire thing weighs. So we'd have 3 carbons times 12 gives us 36 for those. Hydrogen is 1 times 7 gives us 7 for that. And 1 times 35 gives us 35 for that, so that gives us a total of 42.78. Alright, so from there, what we know is we are trying to figure out what was the total weight of the compound. Alright, so we could do the carbon over the total, because we know how much the carbon is. So 113 over the total equals, and then remember this was carbon and this was total. So up here we know the carbon is 36 of the entire 78 of our process here. Alright, and now that we have proportions, we can just cross multiply. So 36t equals 113 times 78 is 8814. Divide by 36. RT equals 244.833. We need a label. There's our label. So grams. Alright, and there is our answer. Alright. I will be back on Monday to be able to answer any questions that you guys have for this. So have those ready, and you can work for the rest of the hour. Any questions, have those ready though.